Water really is an amazing molecule, and part of what makes it so special is the bonding between the elements that come together to form it. You might already know that the atoms of all elements like to have a full outer shell of electrons. If you need a refresher on this, have a look at this video. Water is made from one oxygen atom and two hydrogens. The oxygen has 6 electrons in its outer shell, but it really wants to have 8. The hydrogens have one outer shell electron, but they want to have 2. There aren't usually lots of spare electrons just flying about the place, so the atoms share their electrons, as shown, forming covalent bonds. Now all 3 atoms have full outer shells and are very happy. A water molecule is created. We draw covalent bonds with a single straight line between the 2 atoms that are electron sharing. But you shouldn't draw a water molecule like this. It should actually be drawn bent, like so. The reason for this is down to the lone pairs of electrons on the oxygen, the ones not being shared by the hydrogens. They repel the bonding pairs and push them closer together. So, water has 2 covalent bonds. But of course, the bonds aren't the same as those you would see in, say, methane. In this molecule, the bonding electrons spend most of their time about halfway between the carbon and hydrogen atoms, but in water the bonding electrons spend most of their time nearer the oxygen atom because it is more electronegative, that's electron withdrawing. What effect do you suppose this will have on the different areas of a water molecule? Pause the video and resume when you have an idea. Well, the answer is, because the negatively charged electrons spend more of their time around the oxygen atom, it becomes a little bit negative itself, while the hydrogens become a little positive. We call this delta positive and delta negative. So water has what we call polar covalent bonds and is a polar molecule. This is really important, as we'll see in this video.